So we have our toy up here, and we want to be able to develop graphs for inverse functions. For this, we need to remember some stuff. But let's do this the easy way. Okay? So I want to just start with an example. I want to draw x to the 1/3. Just told us?
Yeah.
I know a function that's a little bit like x to the 1/3.
Yeah.
Say that louder.
X cubed.
Yeah, I might think about x cubed, right? Those should have some kind of reasonable relationship. You guys see this?
Mm-hmm.
Okay, so on my toy here, I'm going to draw x cubed. Kind of roughly. Cool? Questions about why x cubed looks that way? Y'all remember the whoopie? Okay. Now, what I want to think about is what does a point on here look like? It's an x, y point, right? So if it's on the graph of f of x is x cubed, right? Those points look like what? Yeah, they look like x, f of x pairs, right? So they look like stuff and stuff close cubed, right? You guys see that? Okay. They look like stuff and stuff cubed. What do points on f inverse of x is the cube root of x, right? Or x to the 1/3 that I was thinking about before. What do those things look like?
Stuff and stuff cubed.
Stuff cubed. And
Those
stuff.
like maybe like stuff cubed and stuff.
Yeah.
Yeah.
Does that make sense? That would maybe make better sense if I thought this way. So here I've got stuff. I'm going to cube it. So over here I'm going to get stuff cubed. Then my inverse function, right, should undo that, right?
Mm-hmm.
So it should take stuff cubed and turn it into stuff. You guys see that?
Yep.
What's the relationship between this thing and this thing?
You're like reciprocal.
They're like, yeah, kind of opposite-y or something.
Mm-hmm.
Right? What happened? I flipped this was the x, and now it's the y, and this was the
Y.
y, and now it's the x. So if I took my picture, right, what do I want to swap?
We flip over each.
I want to swap the x's and the y's. So do you guys have a suggestion as to how we could move the plexiglass to swap the x and y's?
Flip it over. Right?
You guys want to come try? Somebody got an idea that they want to try?
Flip it over top of the
Come on. Got it? So move your hand. So what happened? So the x's are still x's, right?
Mm-hmm.
And what happened to the y's?
Still.
They're not quite still y's, right? Because still y's would be up there. Now they're,
Inverse of y.
yeah, they're minus y's. So we left the x's the same, we switched the y's. We don't
So
want
you
to do
still
that.
gotta flip it
So we gotta flip.
that way too. Nope. Nope. Nope.
Yeah.
No.
Try something. That's good.
Yeah, that way.
That way?
That's the same way as you just had
You
it.
still-
No.
Wait, wait. No, that's different. Okay, what's different? What did we
Yeah, that's
switch?
like down
Negative
here.
y's?
The y's are minus y's,
The
right?
x's are negative.
And the x's are minus x's.
But we don't have.
So
minus
we,
x's and
we've
x's.
got them almost. Okay, now we've got the, shoot, the y's are the same and the x's are switched. Do you guys see that this is actually a hard game to play? It really is. So let's see.
Wait,
Yeah, turn it sideways.
If we go back to where we were. Okay.
Yeah,
Just
we're
move
flipping the
this
X's
way.
to the Y's, and we're flipping the Y's.
Do you want to do this?
Yeah.
So that's just like tilt, it's not a flip.
Spin the wheel of, or the plexiglass of
Now we have
fortune.
negative X's.
Like that? Okay, now I've got the Y's right, but the
X's are negative,
Oh,
so
so
flip
flip
it.
that.
X's are opposite.
Flip it.
So,
Horizontally.
Yeah, I can do that.
like that?
There you go.
Yeah, that's where we started.
No.
No,
Uh-oh.
it's
Presents.
There we go.
See, it's not where we started? The X's are now Y's,
Oh.
and the Y's are now X's.
Oh,
That's it?
So, do you see that this is the graph of the cube root of X?
Yeah.
This is true for functions and their inverses, right? Because functions and their inverses are always related this way. They're always, right? They're an x comma f of x. And the inverse function is going to be f of x comma x. Right? You guys see that? Because it's the undoing function, right? It takes stuff that had f done to it and undoes. So it's always going to switch these roles. And there's an easy way to see this on this picture. So, let me see. So,
The dot like stays in the same spot.
that's where I started, right?
Right.
And the middle should stay where it is.
Mm-hmm.
So how can I want to switch this one and that one, right?
Mhm.
Turn it. No, I leave it
You guys see that?
Mhm.
Like this? What am I flipping it over?
Diagonal here. The diagonal axis. Whatever that is.
Oh, whoops, I did a crappy job drawing that. What line is that? You guys recognize that one? Yeah, that's y equals x. So to get the graph of an inverse function, you can take the graph of the forward direction and then go like this. Flip it over, y equals x. Cool?
Mm-hmm.
You guys see that? So this is a general rule. When you've got the graph of any function at all, you can flip it over y equals x and get the graph of the inverse. You should be careful for one thing that we probably don't have time for, but I'm going to say anyway. Why doesn't this work for x squared? Like, why does x squared cause us a headache?
Is it not?
There's negatives. Negatives are just the silly.
So,
You're not going to get
Always
negatives
negative.
back.
yeah, let me draw x squared quick because we have no time, but I really want to do this.
The parabola, right?
Yeah, so x squared's a parabola. So x squared looks more or less like this, right?
Mm-hmm.
And then I should flip over y equals x, right? So this is my function, x squared, and I want to graph its inverse. That should look like this, right?
No.
What's the problem?
The vertical line test.
Yeah, this thing fails the vertical line test.
Mm.
Okay, see that? So what did we learn? X squared doesn't have an undoing, that's a function. But we already knew that because you need the plus or minus, right? The reason you need the plus or minus is you have to account for the top half, that's the square root function, and the bottom half, that's the minus square root function. You guys cool on that?
Mm-hmm.
All right, so when you run into something that's an even power, it doesn't have an undoing. Be careful. And the reason it doesn't is because of this vertical line test.